Welcome to MCB Chem 2 online chemistry tutorial. Today I will discuss to you about the topic Knoevenagel condensation, Darzen condensation and Reformatsky reaction. So coming to Knoevenagel condensation, it is a condensation of aldehyde or ketone having no alpha hydrogen which condense with the active hydrogen compound, methylene compound like this. When it bonded to an electron withdrawing group like aldehyde, ketone or acid, ester, cyano and etc. In the presence of a very mild base, for example piperidine, it forms a condensation. It can undergo condensation with these two hydrogen and oxygen get removed to form an unsaturated product like this. For example, diethyl malonic ester can be added to nucleophilically added to the carbonyl in presence of base and it form an unsaturated compound like this. Proposed mechanism for this reaction is, first, this malonic ester can form enolate in presence of very weak base. Here you need very weak base only, because if you are using strong base, this aldehyde or ketone can undergo a self-condensation. And first it form an enolate like this, and this enolate will be added next to the nucleophilically added to the carbonyl, and it form an CC bond here, and it form an intermediate like this. And in this intermediate oxy, it is highly electron dense region, and it can undergo an acid base reaction and it form an hydroxy compound like this. Then this hydrogen get removed, then the remaining base can help it to remove water like this, and it form an unsaturated compound. And second mechanism is the enolate can be added to the imine or ammonium salt. So first it form carbonyl can form an ammonium salt like this. Then enolate can be added to this ammonium salt and it form an intermediate like this. This is the another proposed mechanism. And finally this can be hydrolyzed. And another type of Knoevenagel reaction is, you can use, instead of malonic ester, you can use malonic acid. If you are using malonic acid into the carbonyl in the presence of piperidine, you get this compound, and in presence of base, it deprotonates one of this carboxyl group and it undergo decarboxylation and carbon dioxide get eliminated. Also, water get eliminated out of this, and it form an unsaturated carboxylic acid. So you're using, instead of ester, if you're using dicarboxylic acid, you get monocarboxylic unsaturated monocarboxylic acid. Another example, one example for this reaction, aromatic aldehyde in the presence of piperidine, it react with the malonic acid, it form unsaturated carboxylic acid, that's cinnamic acid. And this is next one is the modification of Knoevenagel reaction. Instead of piperidine catalyst, if you are using pyridine, that is called Dobner modification of Knoevenagel reaction. So malonic acid in the presence of pyridine, it first form an enolate. This enolate can be added to aldehyde and it form a product like this. Finally, it get dehydrated to give cinnamic acid. Only the difference is the catalyst. You can use pyridine instead of piperidine. This is called Dobner modification reaction. An example, another example, acrolein can be treated with malonic acid in the presence of pyridine, and it forms conjugated acid like this. And this Knoevenagel reaction is more useful in aromatic compound than aliphatic. What is the problem with aliphatic? Aliphatic, if you are using aliphatic compound, it first form the unsaturated product, and this unsaturated product, another molecule of and diester can be added to here, and it undergo a reaction like this, because this reaction is called Michael addition. Michael 1,4 addition it can undergo. Another molecule of diester can be added at this carbon, and it forms a structure like this. So it always more useful in aromatic compound than aliphatic compound. Usually ketone does not undergo Knoevenagel with malonic ester or acid, but ketone can react with this more stronger electron withdrawing group like cyano. That means get more activated. So next condensation reaction is Darzen condensation. It is also called Darzen glycidic ester condensation. And in Darzen, aldehyde and ketone can condense with alpha halo ester. This is a ester, and alpha position you have an halo compound, and within one active hydrogen compound here. So alpha halo ester, in the presence of base, it gives alpha beta. This is alpha position, and beta position, it is epoxy ester. This bond is called glycidic ester. Usually it is aromatic aldehyde and ketone give good yield, and aliphatic aldehyde give poor yield. And coming to the mechanism, first one is the Knoevenagel type reaction. In presence of base, this alpha halo ester, it can form an enolate, like in Knoevenagel case, we have seen diester is forming an enolate like this. So it can form first an enolate like this. This enolate can be added to the carbonyl, and it form an intermediate an oxy compound like this, and it can undergo internal SN2 reaction. And internal SN2 reaction, this oxy compound can push out this chlorine, and it form an epoxide. And this is the mechanism of Darzen condensation. And one possible extension of Darzen condensation is, in presence of acid, this epoxide, the ester can be hydrolyzed, and this epoxide can protonated. Then what happens is this can undergo decarboxylation and undergo a rearrangement like this. Or how it can undergo decarboxylation? This hydrogen get deprotonated, then it form a double bond here, and this carbon dioxide get eliminated. Then this bond break. So you have an electron here. This can form a double bond by breaking this CO bond. So you get a double bond here with OH, this OH here. And this is an enol form. This enol can undergo keto-enol tautomerism, and a more stable ketoform will be formed. And in overall, you can see here, and carbonyl, it's converting into, and it is extended at this position, you get a CHO group. This is our study material. This is the carbonyl, and here instead of oxygen you will be getting a CHO group. That is the overall process happens here. And here R dash, suppose R dash is hydrogen, you can see here the product obtained finally is CHO. This ketone group, in this ketone group you get another CH bond. Another example of Darzen cyclopentanone in the presence of alpha haloester, you get an epoxide. And this is the one more example. This substituted benzaldehyde in present react with alpha haloester and it form an epoxide, and in presence of acid it undergo rearrangement like in previous step, and finally you get this product. And another variation of Darzen condensation is with enone. This is enone, called enone with alpha hydrogen. With hydrogen here can undergo, in presence of base, can undergo a rearrangement like this. Hydrogen can be deprotonated and it form a double bond here. Then it can enolate like this. This enolate can be added to the carbonate and it form an epoxide. Another example for this type of reaction is this one. This here, this hydrogen get removed and this form an enolate like this. This enolate will be added to the carbonate and it form a final structure like this. Next one, Reformatsky reaction. Actually, this is not a base catalyzed reaction, but here we are not using, in previous step we are using, everywhere we are using base, but here the similarity with the previous one is we are using an enolate with an aldehyde or ketone, reacting an enolate with aldehyde or ketone. The enolate used for in Reformatsky reaction is alpha bromoester. Alpha bromoester react with zinc and metal in tie-ethyl ether. It form an enolate like this is called Reformatsky reagent, Reformatsky enolate. It forms an enolate like this. Actually, enolate structure is, the real structure is like this. This is not a good structure. And this enolate will be added to the carbonate. Like in everyone, in previous reaction, we have seen condensation, formation of enolate, and this enolate is added to the carbonate, and it form an intermediate like this. Finally, this get hydrolyzed, and it give an beta hydroxy ester. So this is the first product of Reformatsky reaction. So enolate usually with aromatic aldehyde in the presence of base, in some cases it can undergo, in aromatic cases it can undergo an elimination and it form an unsaturated compound like this. So in presence of alpha bromoester and benzaldehyde, it first form beta hydroxy ester. In the presence of base, it first dehydrated, water get eliminated, and on hydrolysis this ester get hydrolyzed and it form an unsaturated carboxylic acid, that's cinnamic acid. And another example is this lactone based alpha bromoester can be added this enolate to, it can form an enolate with zinc, and this Reformatsky reagent can be added to the aldehyde and finally it form a structure like this. And this can also be used for synthesizing into acetic acid. So this synthesis alpha bromoester used this one. This can be added to this compound. Then first it form an enolate. Here this is the enolate, and this enolate can be added to the carbonyl and it form an hydroxy compound like this, and finally in the presence of acid it get dehydrated. Usually it form dehydrated product like here, but more stable structure will be this one, dehydrated. That's all. Thank you for watching, and please subscribe my YouTube channel.